Okay, so today we're working on chapters 3. We're going to finish up 3.2, and we're going to do 3.3 measurement of position. Don't forget that Excel Lab 1 was technically due last Thursday, so make sure you get that in. You can turn it in late for full credit until this Thursday. Also this Thursday you have Excel Lab 2 due, so try to get that in by Thursday. But again, you have until next Thursday to turn it in late for full credit. Connect Math 3.1 is due on Friday. And then right away we have another one due on Sunday, Connect Math 3.2. And then Connect Math 3.3.3.4 is due on next Tuesday. You're going to need, for the quiz, this is a computational model, which you guys all have written down, hopefully on, I think, the bottom of page 3 of your notes, I believe it is. Maybe page 4. No, bottom page 3. So hopefully you guys wrote that down right here in the bottom page 3. Here it is again, and it'll come up, during the course of today. The reason why you have this one is on the quiz, problem 6b. I want you to try using it, even though you don't need to on that problem, because you'll get some practice on how to use it, so that when you get to the homework problem, you can use it on the homework problem. Because remember, anytime your mean has a decimal in it, you want to use this version instead. Otherwise, you will bang your head against the wall and cry and be very, very upset. Right? This is the one you want to use. So make sure that that's why we're doing it today, so you have a chance to practice it a little bit, so you get used to it a little bit before we, before you get it on your homework. So last class we talked about the measures of center, right? The values in the center of a data set. So for example, the first main one that you guys are used to is the arithmetic mean, right? So that's when you add them all up, you divide by how many there are, right? That's what you guys usually think of when you think of the word average. All right, and then you have some notation. So these are from page 4 of your notes. Right at the bottom of page 4, you have all these little fill-in-the-blank things. So you should be filling those all in. You should have filled these in last class, but if not, fill them in now. So sum, that's that kind of backwards E-looking thing. That denotes the sum of a set of values. That means you're going to add them all up. X is the variable usually used to represent the individual data values. So it means X means each individual data value. N represents the number of data values in a sample. Capital N represents the number of data values in the whole population. And again, you should have filled that in your notes, or you should be filling it in now. And then we have X bar, pronounced X bar. Great, not that difficult. That's the mean of a set of sample values. So X bar is for a sample, so it's a regular letter. It's not a Greek letter. Whereas mu is for the population. That's a Greek letter. Right? Pronounce mu just like the Pokemon Mew. And it's the mean of a whole population. How do you find the mean? You sum up all the x's and divide by n. Divide by how many there are. Okay. So, Nicole wants to read. Go ahead, read. Nicole?
Advantages. Sample means drawn from the same population. Sample means drawn from the same population tend to vary less than other measures of center. Takes every data value into account. Disadvantage. Is sensitive to every data value. One extreme value can affect it dramatically. It is not a resistant measure of center.
Right. By resistant, we mean it's not resistant to outliers. So if you guys remember the video yesterday with Michael Jordan, how he dragged all of the average of geography majors from UNC that year really high because it's an outlier. So means, if you have an outlier, it'll pull your mean off of where it should normally be. Here's your quiz 1. Right? Pretty straightforward. Add them all up, divide by how many there are. should all have that. See? Round off rules. So remember, your mean should have one more decimal place than your data is in. So if my data was like 1.7, 2.2, 3.1, 2.7, and just say it averaged out to, I don't know, 2.364. I would round that off to 2 decimal places. Why? Because my data has 1 decimal place. My mean should have 2. So I would round it off to that part there. You look at the next one over. If it's 4 or less, you round down. If this one is 5 or more, I would have rounded up to 2.37. So you have to look at the next decimal place and figure out if you're going to round up or down. So here it's 4 or less, so I'm going to round down to 2.36, which is less than 2.364. Okay. Good. Median. What am I reading? Oh, good.
The middle value and the original data values are arranged in order of increasing or decreasing magnitude, is not affected by an extreme value, is a resistant measure of the center.
Perfect, thank you. Right, so in other words, here's my median. It doesn't matter where the last value is 100 or 100 million. My median is still going to stay the same. It doesn't get shifted or pulled because of an outlier, an extreme outlier. It's resistant to outliers. It doesn't get affected by them. How do you find the median? First, sort your values. Arrange them in order, smallest to largest. Then, find the number in the exact center. If there's one in the exact center, that's your median. If 2 of them are tied for the center, you take those 2 and you average those 2. And that would be your median. All right, so you guys have found your median. I put these guys in order. There's one in the center. That's your median. All good? Your next problem was this one. Put them in order. There's 2 of them tied for the center. So you have to average those 2, and you get 0.915. So you'll notice sometimes the median will have 1 more decimal place sometimes than your original data is in. It could happen. Okay, everybody good with these parts? Yeah. Okay. Mode. How about Drew? Go ahead and read.
The value that occurs with the greatest frequency is the mode. Data set can have more than one, or no mode. Bimodal is 2 data values occur with the same greatest frequency. Multimodal is more than 2 data values occur with the same greatest frequency. And no mode, no data value is repeated. Mode is the only measure of central tendency that can be used with nominal data.
Right, thank you. So nominal data, another is labels. So it's the only way you can use with labels. Because you can find what shirt color or what car color occurs most frequently. You can't find the average of all car colors. So here's your quiz on modes. The first one, there are 2, 1, 10, so that's your mode. The second one, 27 and 55 are tied for first. They both have 3, tied for the most, so it's bimodal. And then C, none of them has more than any other one, so there's no mode. All right, weighted mean. Right, so this is when some x values, some have more weight than other ones. In other words, their frequency is higher, or they're weighted more heavily. For example, your final is weighted more than exam 1. So it should be counted more. So what we do is we take every x value and you multiply it by its weight. So that way if it's weighted more than another one, it gets counted more in the total. And then you divide by the sum of the weights. Remember though, how to tell the difference between your variable and the weights. You never divide by your variable, you divide by the weights. So your variable is the thing that changes from person to person. So you don't divide by that, you divide by the other thing. So if you have trouble figuring out which one's which. So your problem is this one here. right? And again, I strongly suggest you need to change these weights to decimal places, right? So 12% is 12 cents, 0.12. 4%, how do you write 4 cents in real life? 0.04. 15 cents, 60 cents. All right, and then you're going to multiply every value by its weight. Multiply every value by its weight. And then you're going to add them all up and divide by the sum of the weights, right? Because what varies from person to person? Their grade they get in the class, or how much, or how much each part is worth. The grade. So you don't divide by that. All right. So I want to take another minute and a half. Is that enough time? So take a minute and a half and finish these ones out. So at home, pause until you finish this, and then start up again. All right, so let's take a look at this one. So I've got, here I have 60% is 0.60, 9% is 0.09, and I'm going to multiply these. So 80 times 0.12, what do you guys get for that? 9.684. Next one? 2.588. Next one? 13.5. Next one? 46.58. Next one? 4.914. Right, and again, like these folks are all doing, don't round until the end.
Is it 46 or 47? Sorry, 47.68.
Is that right?
No, it's 46.
46.68?
Yeah.
My bad. So don't round until the end. All right, so now you're going to add them up. And you're going to divide by the sum of the weights. So I have to add my weights, I'll get 100%, which is just 1. If I add these up, I'll get 77.366, which I'm going to round to, let's see, this has 1 decimal place, so I want 2 decimal places, so I need to look at the next one. That's 6 or more, so I'm going to round it to 77.37. Oh, sorry, divided by 1. 77.366 divided by 1, which is going to equal 77.37. Everybody good with 1 divided by 1? If you add up all your weights, you get 100%. 100% is 1, right? So another way of looking at it is, if you kind of look at this in terms of here's my whole grade. The first part is worth 12%, so this part here, and I got 80% of that. So I achieved 80% of this. And the next one I got 64% of that, 65% of that. So this part here I got 65% of it, so about 2/3 of it. And the next one I got 90% of that, so most of that. And the next one you got, how much of that one? 78%. I got 78% of that. So, oh wait, I'm sorry. That's 15%, 9%. They got 78% of the whole of this big part. So 78% of that. 7%, 78%. It's about like maybe like this. Need a bigger thing for this. About all this part here. And this last part, they got 55% of this small section here. So out of their whole grade, this is the shaded part they got. They kind of like moved all the white parts and parts all and shifted it all together. Then you kind of see, oh yeah, they got about, on total, ended up being 77% of this whole thing. Does that sort of make sense? But like getting 78% of this big part really helps them out. That's weighted more. So it's worth more of the pie. So if that helps you guys visually better. I just was thinking about that right now. Okay. So some people say, well, how can you divide by 5? And if you try to divide it by 5, you'd end up with a grade of like 15%. Did this person deserve a 15% on their for the total grade? No. So you just kind of think a little bit of common sense. Yeah.
Would 77.4 also work as an
Yes. Say 7.4 would be fine too. Yeah, I'd be all right with that. I'm just going with that rule of the average being one more decimal place than the data is in. Okay, rounding off rule for measures of variation. So variation, you guys remember that, standard deviation and variance, that also has one more decimal place than the original data is in. Just like the mean. The standard deviation, S, it's kind of a measure of how far data values are typically, how much they deviate from the mean, right? How far they range away from the mean. So it's sort of a measure of about, on average, typically how far are values away from the mean. Some are more, some are less. Some are closer, some are further, but kind of typically how far do they mostly fall? That's kind of the sense of it. So if you guys remember, this is our formula for the sample standard deviation. This is the one that's important, right? This is the one you'll use because we never deal with whole populations. We only deal with samples in this class. So the sample standard deviation is the one we're going to use. So we'll notice that in the sample, when we average, we add them up, we sum them, we divide by n minus 1 instead of n, because they need to be a little bit larger, because especially when our samples are small, our standard deviation we've calculated is more likely to be off a little bit. Our mean is off a little bit, everything's off a little bit. So here are the steps. First step, take every x value, subtract it from the mean. That's your first step. Second step, square all those values. Third step, sum them, add them up. Fourth step, divide by n minus 1. And last step for the standard deviation, square root it. That's your good step. Right? Those are kind of the 5 steps. And you guys want to do that. This is we call it theoretical model. Why? Because you can find it in theory. We went through the theory of why it makes sense yesterday. You will have to, on the exam, do a problem similar to your quiz problem, right? Like 5 or 6 numbers. It might be a little harder numbers, but they'll still be like 1-digit numbers. Finding the standard deviation, because I think it's important for you guys to prove that you understand where it comes from. Right? This is where it comes from. It comes from finding how far every value is away from the mean, squaring all those values, kind of averaging those, and then unsquaring it. So this is the one you're supposed to use for 6A. Quiz 6A on the back. There's also the computational model we'll talk about in just a minute. So let me just mention a couple things about variance. So here, again, back to that bottom of page 4, right? Variance notation. S is your sample standard deviation. S squared is your sample variance. Usually we use most just regular S, but those two are related. If I want to find the variance from the standard deviation, I square it, right? So I take S. If I square S, I get S squared. If I square the standard deviation, I get the variance. If I have the variance, I want the standard deviation, I square root it. The square root of S squared is S, because the square root of the variance is the standard deviation. You'll also notice that S is just a regular ordinary letter because it's for the sample. It's a statistic. For the population, it's a Greek letter, sigma. Sigma is my population standard deviation, and sigma squared is my population variance, because our parameters for our population, those are always going to be Greek letters. So fill in your blanks if you need to. And formula, okay, so this formula, let me give you this one, right? So here's the computational formula. Make it a little bit larger. point out a couple things about it. So the first thing is, first, you're going to square every x, right? And then add them up. That's what this first part means. It means square the x's first, then sum them. Because squaring exponent takes precedence over addition, over summation. And then once you find that, if you add up all the squares, then multiply it by n. Minus this other part. This other part means in parentheses takes precedence over everything. So first, you're going to add up all the x's, and then you're going to take that sum, after you add them up, and you're going to square that. So this one means first add them up, and then square that. After whatever you get when you add them up. Okay? So why don't you go ahead and do quiz number 6. I'll give you guys, I don't know, 2, 4, 5 minutes maybe? We'll see. 4 or 5 minutes. So pause at home until you finish this.